Okay, we're continuing the 3.4 practice quiz. All right. And we are on letter F. During what time intervals is the particle moving to the right, to the left, and where is it when it changes directions? All right, so remember it changes direction when it stops, so we know it changes directions at t equals 3 seconds. Now that's the when. If we want to find the where, we can always go with the position function because the position function will tell me where it is at any time. So I've got the time. So that's going to be how we do H. But let's do F and G first. During what time intervals is the particle moving left or right? All right, well, F. So I'm going to draw a line here. Okay? And this can represent a timeline. Time. And I know it stops when t is equal to 3 seconds. Okay. So I'll just put a 3 there, and that's when it stops, because that's when the velocity equals to 0 when t equals 3. All right. Now, the velocity, remember the velocity is positive. If the velocity as a function of t is positive, greater than 0, that means I'm moving to the right. If the velocity is negative, less than 0, that means I'm moving to the left. So I just need to check the velocity. Now, remember t has got to be greater than or equal to 0, so don't forget that. So we're only going to worry about this part here. We don't worry about anything to the left of 0 because it's going to be greater than or equal to 0. Those were the parameters at the very beginning. When we read the problem carefully, it says t is greater than or equal to 0, so we don't worry about negative time. So let's put a value in my velocity. So let's just put, I don't know, just put 2 in here at 2 seconds. All right, so what's v of 2? Well, if I look at v of 2, that's going to be 2 times 2 is 4. That's going to be 4 minus 6, and that's going to be negative 2. So at 2, I'm a negative, so that means I'm going to the left. Because this is negative, that means I'm going left. So my velocity is negative. That means I'm going to the left. Now if I try 4 in here, let's try 4. V of 4 is 2 times 4, which is 8. 8 minus 6, which is equal to 2. That's positive. So my velocity is positive. So here my velocity is positive. That means I'm moving to the right. Now I just keep going to the right. There's no bounds on the right. So for letter F, it says, during what time intervals is the particle moving to the right? Well, it's moving to the right from here on out, so from 3, so it's moving to the right from t is greater than 3. Not equal to 3 because it stopped there. Or you could write it like this. 3 to infinity, like this. So that would be letter F. And you can do this pretty fast. You just substitute these in. So that's letter F. And letter G. When is it moving to the left? Well, it's moving to the left here at 0. Now, what's happening at 0? Is it moving at 0? Well, if I put 0 in my velocity, what's 2 times 0? 0, so negative 6. So it is moving to the left at 0. So I can say 0 less than or equal to t less than 3, I'm moving to the left. Or I could write it like this, 0 to 3. Okay, that little sound is my cat, Spit. He's playing with his little ball toy, so it rolls around. So you have to put up with that, okay? So that's when it's moving to the left. Moving to the left. So this is right, and this is left. So either one of those will go in for G. You don't have to write that, but just put them in the right place. So this is left. Okay? And then the last one, h. Where is the particle when it changes the direction? Well, the position function will always give me the where, so the position function, s of t, which was equal to t squared minus 6t plus 3. This tells me the where when I have the when, and I know the when. The when is 3 seconds, so what's s of 3? That equals 3 squared minus 6 times 3 plus 3. All right? And that equals 9 minus 18 plus 3. And that equals 12 minus 18, which is negative 6 and meters. So I'm going to be at negative 6 meters. That's when I'm moving. That's where it changes direction. That's where it stops. Okay. So if we asked to describe the motion of the particle, we would have to draw a number line, and we did some of this on some of the homework problems. We didn't have to do that. Those are kind of complicated. But we can take a look at the motion by using our calculator and using our parametric mode. So this is pretty cool. So let's take a look at this. We can kind of describe it if we want to look at it. If I drew a number line here, my initial position when s is 0, s of 0 was 3. We looked over here. If we go back and look over here, s of 0 was 3. So I'm going to start at 3. Okay, and then for the first 2 seconds, we're moving to the left. So we're going to start here at 3. And at t equals 0, so then we're going to move to the left. And then we're going to stop. So this is at t equals 0. Then we're going to stop somewhere over here. And now let's find out where that's, well, that's going to be at negative 6. So we already did that. So 1, 2, 3, 4, 5, 6, negative 6. And then, so we're going to go for 3 seconds. And then at t equals 3, we're going to stop. And then we're going to turn around and we're going to move to the right. From then on out. So we start at 0. At t equals 0, we start at 3. Then we move to the left for 3 seconds until we get to negative 6. And then we stop after 3 seconds. And then we move to the right. And we keep moving to the right from then on out. From 3 seconds to infinity. So that's what's happening. Now, on the calculator, we can check this out by going into the parametric mode. So this is pretty cool. So let's take a look at this. All right, and then you've got to put the parametric, turn it on, of course, and go to mode, and make sure we're in the parametric mode. Okay. Okay, and then you can go back to y, and I put my function in. This is my t squared minus 6t plus 3, and I'm going to do this on the horizontal line y equals 2. I'm sorry, yeah, on the horizontal line y equals 2, so I can see what's happening. Okay. And then what we can do is we can use a little 0 there, change this little thing to 0, and now watch what happens. There's the particle, it moves to the left, it stops, and then it moves to the right, and it starts accelerating and keeps moving to the right. Now another way to do this is we could go back to y if we want to kind of lock in a little bit more. We can change this. Now this is the parametric mode. Now, let's go back to the window. This is, you better know your t. So I'm looking at the first 10 seconds of my motion. So I had t equal to from 0 to 10 seconds. My t step is 0.1. You could put 0.13. This is just what was in there. My x is I'm going from negative 10 to positive 10, so I can kind of see what's going on. And my y was just negative 3 to positive 3. So you have to set your window. Sorry, I forgot to tell you that. Okay, so make sure you set your window. And this is basically telling me that I'm checking to see when the time goes from 0 seconds to 10 seconds, and I'm checking it every 1/10 of a second, so to speak. All right, we can change that to 0.1 if you want. So every 10th of a second. So if we go and graph this again there, you can see what's going on. Now that's in the regular function, but the nice thing is you can do the trace, and you can see what's going on here. So this is where we start at t equals 0. Now the y is always going to be 2, so don't worry about that. But that's my initial position, 3. and then we just press this over. That's going to go all the way over until time equals 3. So look at my time over here, and it gets to be exactly 3. And at 3, I'm at -6, which is what we had over here on our sketch that we did analytically, see? And that's at t equals 3. And then I keep going, and then it starts moving to the right, and you can see the little cursor there moving to the right, and it just keeps on moving to the right. Okay? So you can kind of reaffirm what you're doing there. We can go back here, and we can change this. I like this kind of function too over here, where we have a little circle with a line. Oops. There it is, and we can graph it like that, and that kind of traces it out. It goes like that. Slows down and stops, and then it starts moving to the right, starts accelerating to the right, and goes faster and faster and faster and faster and faster. It just keeps going to the right till infinity. It just keeps, doesn't change direction anymore. Okay? So that's a way you can kind of, reaffirm what you're doing on some of these problems if you're asked to describe the motion. Okay? Same idea. We saw it start over here, move this way, slow down, stopped, and just move it that way. Okay? So if that all makes sense.